Very good. Another example, constructing a confidence interval for population mean. So we need to identify the keywords here. We randomly select 36 cars. It means that the sample size is 36. Okay. Let us go to the next line. The sample mean is 9.75 days. Okay, so far so good. I found my point estimate. Next keyword is sample standard deviation. S, or the sample standard deviation, is 2.39 days. Question says, hey, construct a 99% confidence interval for population mean. Okay, very good. So let us take a look at our little board and try to write down the steps, which column that we're going to use. Is it the first column? Is it the second column? Are we trying to find ZC or are we trying to find TC? Okay, perfect. Very well. So here we go. This example is about the number of days the car sits on the dealership's lot. Okay, here we go. Example. The number of days. So the very first thing is, are we dealing with population mean or population proportion? Which one is that? So you need to identify the population parameter that you're dealing with. Remember that. If you look at your columns, you have different columns. Column for population mean is discussed in 6.1 and 6.2. Let us take a look at this. 6.1, population mean, 6.2, population mean, but the scenario is sigma is missing. And the last column that we're going to discuss later is about population proportion. Take a look at the question. We want to construct a 99% confidence interval for what? For population mean. Okay, very good. So far, I know that it's not about population proportion. It definitely is about population mean. The next important piece of information is sigma given or missing? Do we have information about population standard deviation or not? Take a look at the question carefully. The only standard deviation that I see is sample standard deviation. There is no information about population standard deviation. What's the meaning of that? It means that population standard deviation is missing. Sigma is missing. What's the meaning of that? Quickly write it down. It means that we are dealing with T distribution. 6.2 T distribution. Okay, so what is the very first step? In the very first step, step 1, we need the point estimate. Point estimate. What is my point estimate? The best point estimate for population mean is sample mean. Guys, remember that. Sample mean or X bar. What is your sample mean? How do I find it? I need to read the question carefully. The sample mean is 9.75. Sample mean is 9.75 days. I found my point estimate. Point estimate in this case is sample mean, which is denoted by X bar 9.75. Step 2. Well, here we go. What is my confidence level? Confidence level. Confidence level for my confidence interval in the question says, hey, construct a 99%. 99%. The confidence level is 99% or 0.99. What is my next step? Step 3. What is my critical value? Guys, critical value, ZC or TC? Which one? Hey, remember that. Sigma is missing. We are using a t-distribution. It means that we are not allowed to use ZC. We must use TC. T-distribution, critical value, T sub C. How do I find it? If you're using your calculator, calculator says, well, for TI 84, go to second, go to vars and find inverse T. Okay, inverse T. Let's go there and see how we can calculate this critical value. Let's turn on the calculator and then go to second, vars and inverse T. Inverse T is just right here. Let's click on that. Well, the area, what is my area? I need to find the area. The area, as you remember, is 1 minus C divided by 2. But what is C? C is 99%. So it is 1 minus 0.99 divided by 2. So my area is equal to 1% divided by 2, which is 0.005. This is my area, 0.005. What about the degrees of freedom? The degrees of freedom is n minus 1. But what is n? What is my sample size? Let's take a look at the question. I do remember. What is the sample size? It says you randomly select 36 cards. 36 is n for the sample size. Very good. It wasn't that hard to locate 36. So my degrees of freedom is 35. Degrees of freedom, DF, 35. Here we go. Let me find TC, which is 2.72. So TC is 2.72. Remember that it must be a positive value because we're going to use this guy to calculate the margin of error. Margin of error as a distance must be positive. Let's take a look at our table, T-table. Let us verify that we have a correct TC. So let's take a look at our T-table. Our T-table says, hey, my confidence level is 99%. Okay, this guy is just right here. The degrees of freedom is 35. I don't have 35, guys. If you open different T-tables, you might not get the exact value 35. What are you going to do? You're going to find, for example, a number in between 30 and 40. Or if it's closer to 40, you're going to use 40. If it's closer to 30, use 30 as your degrees of freedom. So when you're using your T-table, as you can see, 99%. If you're using 30, you're going to have 2.75. If you're using 40, it's going to be 2.704. You can find the average between these two numbers as well. But again, if you are using a T-table and you don't have the exact value, use the value closest to the degrees of freedom that you have. For example, if I use 40, it's going to be 2.704. Perfect. So what is the next step? In my next step, I'm going to compute the margin of error. Do I have a formula for that? Yes. E is equal to TC times S over square root of N. What is TC? 2.72. What is S? Well, I don't remember. What was S? What was the sample standard deviation? S or the sample standard deviation is 2.39 days. 2.39, okay. 2.39 divided by square root of what is N? N is the sample size for 36. Okay, if I do the computation, the margin of error is approximately 1.09. This is the margin of error. In the last step, step 5, the confidence interval is parenthesis x bar minus e, comma x bar plus e. Let us close the parenthesis. It's going to be, well, since all of these are approximation, use approximation. X bar, the mean of the sample is 9.75 minus the margin of error 1.09, comma the mean, which is 9.75 plus 1.09. So the confidence interval approximately is, okay, 8.66 days to 10.84 days. And as a statistician in your report, you're going to say that we are 99% confident that. The population mean days is between 8.66 days and 10.84 days. Now, how do we use our calculator to actually make sure our computation is correct? Very good. So these are the steps that we took to build the confidence interval. We need to double check our answer. Let us use our calculator to double check that we actually have a correct confidence interval. So to use your calculator, you're going to turn on your calculator. Let me write it down. Calculator confidence interval. Calculator, then we are dealing with the T distribution. So here you have the T distribution. What are you going to do? You're going to go to stat. So go to stat. Go to tests. And then find T interval. T interval. So stat, tests, T interval. Okay, very good. So let's click on T interval. Okay, we don't have the actual data. What do we have? We have information about our sample or sample statistics. So enter. So what is X bar? X bar is 9.75 days. X bar 9.75. Okay, very good. I enter this here, X bar 9.75. What is S sub x? What is the sample standard deviation? Sample standard deviation is 2.39. 2.39. What is N? What is the sample size? It is 36. Okay. And what is the confidence level? It is 99% or 0.99. Okay, let us do the calculation. Okay, let's wait a little bit for this guy to show the result. If you're using your calculator gives you the confidence interval as 8.67. Okay, pretty much close. And 10.84. Okay, so the confidence interval is 8.67, 10.84 days. So this is how we use our calculator to make sure our computation is actually correct.